So now that I've given you an overview of patterns, and particularly the patterns we're going to be using in the context of the discussion of Android and Java concurrency frameworks, let's take a look at mapping some of the classes in Android's concurrency frameworks to the patterns that we're going to talk about in more detail. This is still kind of giving you a bird's eye level view of what's to come. So again, we're going to talk about some of the classes that exist in Android's concurrency frameworks. So not surprisingly, Android's concurrency frameworks are built using a bunch of reusable classes. And you can see some of the classes listed here, and we're going to go through them one by one. And we're going to take a look kind of at the interface, and we're going to be talking about how the patterns are used internally to implement the interfaces of the various classes. So these patterns naturally come out of some of the classic literature on patterns. There's the patterns from the Gang of Four book, which don't really relate to concurrency per se, but are important for other purposes in terms of how you make objects and how you design classes, and you provide dependencies from superclasses to subclasses and so on. And then there are also a whole slew of patterns from the POSA 2 book and some other books in the POSA series, which are definitely related to concurrency and synchronization. So we're going to focus on the most important classes in the Android concurrency frameworks. As you can see here, these are looper, message queue, handler, message runnable, and then some stuff that's part of the async task framework, executor and FutureTask. And some of the classes are used by all the various concurrency frameworks in Android, and others are specific to one or the other. So the first class we're going to talk about very briefly, and then we're going to look at a pattern that is used to help structure its design, is the looper class. And the purpose of the looper class is to run a message loop for a thread. And so typically you do this because the Android framework, especially the user interface thread, wants to have this thing called a looper, the main looper, and it just sits there and waits for events to show up in its message queue, and then it takes those messages and does stuff with them. And that's how things are processed by the main user interface thread. You can take a look here and learn more about the looper class. We're going to see shortly, I think this is actually the first thing we're going to talk about, the looper class uses the thread-specific storage pattern to ensure that there's only one looper per thread. So we only want one instance of a looper for the thread that's being used to process requests that come into that particular looper. So that's a way to ensure that that takes place. So again, this is a POSA 2 pattern. You can see the pattern description at the link below, or you can take a look at the POSA 2 book, which has a more refined description of the pattern. Another portion that's part of Android, another key class in its concurrency framework design, is called message queue. And it basically holds a list of messages that are intended for being dispatched by the looper. So the looper will sit there basically pulling things off the message queue and processing the messages one at a time and doing whatever they're supposed to be doing. You can read more about that particular class at this link. And it basically is just a message queue that will block when the queue is empty, waiting for work to do. Internally, this particular implementation applies the monitor object pattern to enqueue and dequeue messages concurrently and efficiently. And we've talked about monitor object before. We're going to talk about it in a lot more detail here. And you're going to see how this particular queue is implemented under the hood using the monitor object pattern. And you can read more about the monitor object pattern either in the POSA 2 book or at the link at the bottom of the slide. Then there's something called a message, and that's, surprise, surprise, what gets put into a message queue. And the message contains data and type information that can be sent to something called a handler via a message queue. And you can read about messages here. And messages are created using the factory method pattern, which is one of those good old Gang of Four patterns, arguably one of the most common Gang of Four design patterns used. And it basically allows the separation of creating of a message from its use. So factories are always about hiding the implementation details. The next element we're going to talk about is called a handler. And handler is a class that's used to allow sending and processing of messages. We just talked about messages and runnables. We're about to talk about runnables. And it basically is used to process these messages or runnables that are given to it through the message queue that's associated with a threads looper. So now you can start seeing all these pieces are coming together here. So we've got handlers. Handlers are how you pass messages or runnables to a message queue, and then the looper is used to pull the messages off and run them in the context of a thread of control. And you can read more about handler here. As we'll see, and this probably won't happen today, but it'll probably happen next time, handlers support the active object pattern as well as the command processor pattern. And these patterns are used to allow sender and receiver threads to run concurrently. And you'll see that active object and command processor are very important patterns that are implemented in Android. I've mentioned runnable before. I think you already know what a runnable is because we've talked about a runnable a whole bunch when we talked about threading and we talked about the executor framework. And a runnable basically represents a command that can be executed. So you can take a look at runnable here, and runnable basically supports the command processor pattern because it's passing runnable commands that are going to be created in one thread and then passed to a different thread where they're going to be executed. And the most common way that this works is some background thread will create the command and then it'll send it through a message queue to a handler, which will then be responsible for processing that command, that runnable, and that is the command processor pattern. So you can read more about the command processor pattern here. And all the classes we just looked at are used by both the Android Hammer framework, which stands for handlers, messages, and runnables, or Hammer. And it's also used by the async task framework. There's also a couple of classes that are only used by the async task framework. So one of them is FutureTask. We've talked about FutureTask much earlier, and that's used to start and cancel an asynchronous computation, query to see if the computation is complete or if it's been canceled, and then retrieve the result of the computation if it was not canceled. And you can read more about FutureTask here. Again, we had a whole video series on it. If you recall, I used FutureTask in order to show how to implement one of those atomic check then act capabilities like compute if absent that you might find in the concurrent hash map in Java 8 and beyond. The FutureTask, of course, supports the future pattern. And that's a pattern that's documented in a couple places. It appears to some extent in the POSA 2 book. It also appears in the POSA 4 book. And it basically is used to block the client only if the computation is not yet finished. And you can read more about futures or promises here at this Wikipedia article. And then the final piece of the puzzle for the async task framework is the executor framework, which we've also talked about in tremendous detail in this class. And it can be used to execute runnable tasks either sequentially in a single background thread or in a pool of threads. And there's a couple different ways to do that. You can, of course, read more about executor here. Go back and watch the videos again if you need to. And the executor framework is used to implement a whole bunch of patterns. It can be used to implement the active object pattern. It could be used to implement pooling, which is a pattern described in the POSA 3 book or at the link in the slide below. And it can also be used to implement the proactor pattern, which is a very interesting pattern for asynchronous communication that's really at the heart of the executor completion service framework that we talked about. So that's the end of the overview of taking the classes that are part of the Android concurrency frameworks, which, as you can see, also leverage many of the classes that are part of the Java concurrency frameworks like FutureTask and Runnable and Executor and so on, and then showing how they are used at a high level, and then also briefly mentioning how they are guided in their design and implementation by various patterns from the POSA 2 series and the Gang of Four books. So we'll talk about these in more detail now, but I just want you to see the big picture view before we start diving into each of the patterns individually.